We never stop hearing about how the internet's in the cloud, but really, it's in the ocean. About 300 undersea fiber optic cables are responsible for 99% of international data traffic. 99% of international data traffic. It's basically the same way we connect to each other in a single country, except underwater instead of underground. They transmit PewDiePie from Europe to America, and they connect stock traders in New York and London. And these cables, placed by private companies, are the backbone of the internet. But if you held one in your hand, it'd be no bigger than a soda can. There are just a few layers of protection from the water, including petroleum jelly. Yes, your internet is covered in Vaseline. They're vulnerable to earthquakes. At least a few times, confused sharks have bitten them. But many cables are beneath sea life because in some places they go as deep underwater as Mount Everest is high. Ships lower a plow that digs a tiny groove in the ocean floor, lay in the cable, and it's naturally buried by sand thanks to the ocean's current. And that process, it's both stunningly simple and mind-blowingly complex, is responsible for making the internet a truly global network. It's an idea that's audacious and crazy, and you think it has to be cutting edge, and it is, but it's also been going on for 157 years. Electric telegraphs have been around for a long time. Experiments in the early 1800s connected two ends of a garden using a clock that revealed letters. Then they moved on to two neighborhoods to help signal trains, and then multiple cities thanks to a network of railroad lines. Underwater submarine cables were an obvious next step, so they played around. Instead of petroleum jelly, the first ones were coated with exotic tree sap to protect them from the water. And though the undersea cables came in spurts, one of the first ones was knocked out of commission by a fishing boat. By 1858, they reached around the Atlantic and across the world. And that's how it's kind of gone since. Laying cables that circle the Earth's oceans. The cables are unwound from the back of the ship, sink to the ocean floor, and the world is connected in speeds measured in milliseconds. There are ideas to bring the internet above sea level. Along with cell phone towers, there's internet beamed from Facebook satellites to Africa and balloons lifted by Google. About 300 undersea fiber optic cables are responsible for 99% of international data traffic.
It's been called the quiet workhorse of space science, a means of transporting ambitious and hefty scientific experiments to the edge of space.
We're going to start inflation at this time. Everybody got earplugs that wants them?
While the technology may seem old-fashioned, it remains the quickest and most cost-efficient avenue to near space.
When you compare to satellite missions that take 5 to 7 years to develop and millions of dollars, scientific ballooning can be done on a fraction of that budget and in a fraction of that time.
From the study of the atmosphere to the origins of the universe, it's been the vehicle for some of the most significant scientific discoveries of our time. And the future holds even more promise for one of the greatest scientific stories never told. They can fly that 8,000-pound payload, the weight of 3 small cars, nearly 23 miles high, to an invisible ceiling where the atmosphere ends and space begins, and can stay there riding upper atmospheric winds for up to 6 weeks. Due to the natural difference in density between the helium gas used to fill the balloons and the air, as these zero-pressure balloons ascend in the atmosphere, they expand to volumes of up to 40 million cubic feet, nearly the size of a stadium like the Louisiana Superdome.
But to launch those into space would take a very expensive launch vehicle. I mean, really, literally on $100 million. for the launch. And whether we do these for, certainly 1/100th of that or less.
And we can have greater access to space, more frequent flights of science, and in the end, the scientist gets their payload back.
From New Mexico to Arctic Sweden and Australia to the coldest and driest continent, Antarctica. The Columbia Scientific Balloon Facility launches 15 to 20 balloons a year over 4 to 5 campaigns.
All right, guys, we're ready.
Locations are typically dictated by science or longer data gathering air time.
Any science that can be done above about 99.5% of the Earth's atmosphere, either looking up or looking down, can be done on balloons.
The scientists using scientific balloons include some of the world's most seasoned researchers and university professors, even graduate students.
The young scientists can design the experiment, build the experiment, fly the experiment, and analyze the data, go through all aspects of a space mission, which is not possible with our large space mission.
And ballooning is a vehicle for world-class science. In the mid-1980s, an ozone hole was discovered over the Antarctic continent. The initial measurements were all made from scientific balloons.
But for speedy international travel, undersea cables are still where companies like Facebook and Google place their bets. That's because the best way to create the cloud is still by going under the sea.
All telephone and data is transferred over submarine cables.
Not satellite.
Not satellite.
Not satellite.
Not satellite.